Welcome to our program, Astronomy for Everyone. This month's show is about comets. And with me here in the studio today is Mark DePrest, a member of the University Lowbrow Astronomers. Mark, welcome to the program.
Thank you. Glad to be here.
Now, I know you wanted to start with the basics about comets, so what are they?
Well, comets are made up of a number of different elements. The easiest way to describe a comet is basically it's a dirty snowball, a great big giant dirty snowball that's floating around out in space. That's probably the most simple and accurate description of them as the lay people would understand. I mean, I could go into all the chemicals and everything that are in it. You know, you got hydrogen, nitrogen, cyanogens, ammonia, oxygen, carbon dioxide, methane, some dust. There's possibly some organic material in there.
Okay.
There's theories right now that claim that possibly life started on planets similar to our own from comets.
The material that was brought to that planet by the comet.
By the comet, exactly.
But basically a dirty snowball.
Basically, a dirty snowball is a great explanation of how they look.
And where do these dirty snowballs come from?
Well, they come from two different places, primarily. The Kuiper Belt is the first one, and in the Kuiper Belt, we get some of the what they call periodic comets. These are comets whose orbits are 200 years or less, and you'll see those listed in a list of comets, and they'll all be designated with a letter P next to them, which means that they've already proven that their orbit does bring them back around time and time again. We have orbits that go anywhere from 10,000 years all the way on down to every 2.5 years. Comet Encke, which is coming through right now, will be visible same time Comet Izon will be in the fall. And it comes around every 2.5 years. I've seen it 6 times.
Oh, okay.
So,
is there any designation between these periodic comets as to the ones that are shorter?
Well,
less than 200 and then more than 200?
Yeah, anything less than 200 gets a P designation. Everything else will get a C designation, plus its year that it was discovered in, and it'll get a letter number designation along with the discoverer's name. That's how they do comets. So we get a lot of people that ask, well, how come the name is so long? Well, it's mostly to honor the person who discovered it, but we also need to classify it as what type it is, because there are 2 different types. The second type comes from what we call the Oort cloud. And the Oort cloud extends from about, maybe 50 times out as far as the Earth, all the way out to what they call the heliopause, or the end of the sun's gravitational field or influence. Out there could be billions of comets, and these comets are basically leftovers from when the solar system first began.
Okay, so we've got those 2 basic type of designation of comets. Obviously, those longer period comets we would never see again in our lifetimes.
Probably not. A good example was one that came through here a few years back. People might remember it. It was Hale-Bopp.
Yes.
That's a 10,000 year plus comet. You know, it made its one shot through here, and that one came from the Oort cloud. A lot of the comets that come out of the Oort cloud will come into the inner solar system one time and one time only. A lot of them never survive their first encounter with the sun, because that's what's pulling them in, is the sun.
And to determine whether they're the longer period or the shorter period, they can tell that by the trajectory of the orbit?
Essentially, after about 3 good positional measurements, and I'm talking, they get exact positions right down to the fractional arc second, and time. They have their times plotted out, and essentially where they feel they are when at that particular point in their orbit. After about 3 of those, they can pretty much tell what that comet's going to do. They can also tell a lot more about its mass, or get a good idea of its mass, which tells them how fast it's going to come through or how large it might be. People get a wrong idea about comets themselves. They're actually relatively small. the largest comets we got out there today that are floating around might be as much as 20 kilometers in diameter.
Which is a little over, what, 10 miles, maybe 12 miles?
Yeah.
Okay.
It's not big at all. So here you only got something that's 10 or 12 miles in diameter, and we get to see it naked eye, and it's out further than the orbit of Mars. That's an incredible feat just in and of itself, plus the fact that they don't create any light of their own. They only reflect light. And they reflect it off of all the little particles that are sublimating off their surfaces. They're basically frozen snowballs. When they get in close to the sun's solar wind will tend to push on this comet, causing the comet itself to sublimate. When it sublimates, it goes from a solid state to a gaseous state all in one instant.
Okay.
And that's what gives us this gaseous outer atmosphere of the comet itself. There's a nucleus, there's a gaseous envelope that surrounds the comet. We refer to that as the coma. And then all that material that's falling off there when it sublimates, the dust and the organic particles and some of the heavier elements that may be within that dust particle, those get strewed off along with that surface. So those give us a trail. Not a tail,
okay.
Not a tail, a trail.
Okay.
Now they'll go off in the same direction when they first start out because the solar wind is pushing them also. These are very small particles, okay? And they get pushed out, and they can give you some gorgeous looking tails, okay? But they're basically the comet's trail. The comet tail that you see in images is generally that ion tail, where the solar wind and the radiation from the sun is actually causing the ions in that surface to sublimate, and they give us that bluish glow that you see in pictures.
So that is the difference. Now,
Yeah.
a few minutes ago you mentioned that these things return relatively small, 10, 12 miles. If something were that big coming at me, I would be a little bit concerned. Are these comets dangerous to Earth?
Well, to Earth, no.
Okay.
The Earth's been hit a number of times. Life on Earth, on the other hand, it usually doesn't fare so well and has to make some kind of a change. The last change was when the dinosaurs disappeared, and we got our chance.
Okay.
So you really don't want a comet to hit you or hit the Earth, but they wouldn't destroy the Earth. Life would go on.
Okay.
It would just might be different.
A little bit different, which I guess would be the difference between like a comet and an asteroid. An asteroid is much bigger.
And asteroids are mostly made of carbon and carbon compounds and a lot of iron. There's not much iron in comets.
Okay, so these asteroids would really...
They'd make a dent.
Yeah.
Yeah, they'd make a big dent.
With the dinosaurs, as you said. So it sounds like these comets are, as you said, bits and remnants left over from the creation of our solar system about 4.5 billion years ago.
Yeah.
And they're still with us to this day. Now, we're going to take a short break. We're going to go to term of the month in just a moment. I do want to encourage you and invite you to visit our website, the address of which is at the bottom of your screen, as it usually is, so it's right there. And after term of the month with Stephen Whitty, we'll be back with more about comets with our guest, Mark DePrest. Stay tuned.
The term of the month for October 2013 is meteor shower. So this month we talked a little bit about comets, or a lot about comets. It turns out that comets and meteor showers are related. And they're related because comets, the dust from comets in particular, gives rise to the little particles that become the meteors that break up. So in this image we have comet Giacobini-Zinner, and we see to the left, going down to the left, we have the tail, and this tail has bits of dust and debris. In the dirty snowball concept of a comet, there is some dirt, and this is sort of sand-sized stuff. And what happens, all right, so in this image, I I should note that the vertical streaks, those are stars. This image, they followed the comet, not the stars. So the stars seem to move, but the comet doesn't. Anyway, the debris, the little bits of dust, they string out across the entire orbit of the comet. So forget about the tail here. Just along the whole ellipse, the whole oval of the comet, the debris spreads out. And when the debris actually, when the orbit crosses the Earth's orbit, that's when the Earth plows into it and we see a meteor shower, little bits of stuff in the atmosphere. And that's term of the month for October 2013, meteor shower.
Welcome back. We'll continue our talk on comets with our special guest, Mark Duprest from the University Lowbrow Astronomers. So we've talked about the fact that these are dirty snowballs. So what do they look like?
Well, they have different parts to them. There are multiple parts. There's a nucleus, which is basically the frozen snowball. Around that, there's something that we refer to as the coma, which is basically I'd call it its atmosphere, basically. It always surrounds the comet once it gets inside the orbit of, say, Jupiter. The sun reacts with the surface enough to create this gaseous outflow.
That sublimation that you talked about earlier.
And then there's always some kind of a small tail that's coming off of it. That's the ions reacting with the solar wind and the charged particles therein. And generally, there's something that they've only just recently discovered, and it's called a hydrogen envelope. And in some photographs that they took back in 1997, they've reanalyzed. Originally, they thought they were part of a sulfur tail on Hale-Bopp. And what it turns out is they were actually seeing this hydrogen envelope, which is a round comet. In all of that stuff is where all the pieces of the comet fall off of it.
Okay.
Comets get smaller as they go along all the time.
Would that be similar to the image that we have?
The image that we're looking at right now. That dust tail that it says on there is actually a dust trail. It starts out following that ion tail and is streamed off that way, and it spreads out as it gets further and further away from the comet, or as the comet moves further and further along its path.
Like a wake widens behind
Like
a
a
boat.
wake widens behind a boat. Very similar to that. So that's what we see most of the time through our telescopes, is that. Depending on where it's in its orbit, you can see up to two tails.
How's that?
Well, you can see the dust trail and you can see the ion tail. Depending on where it is, if it crosses the plane of our orbit, you see that every single time. You'll see one going this way and one going this way with the comet in the middle.
Okay, so that it all depends on our
Yeah.
perceptual position where we are.
It's all perception, where we're at in the orbit. Here's a nice diagram you can see of an orbit of a comet. Once it gets inside the orbit of, say, Jupiter, it starts to sublimate quite a bit. The surface of it sublimates quite a bit. And it starts to develop these tails and these trails, and the material starts falling off of it as it goes.
Now, I know sometimes we've had reports of the comets at quite a distance. Even at that point when they're, I don't know, near Pluto or something, and we hear reports of these comets coming in, are they able to see a tail or a trail, or are they just looking at that hydrogen
Pretty much the comets that they know about. In fact, it's been just recently somebody did another image of Hale-Bopp recently, I saw on the web. But they know their orbits. Once they figured out their orbits and so forth, they can track them down pretty easily. Once they get out into that area between, say, Jupiter, Saturn, and beyond that, generally that sublimation tends to be very quiet. However, there are comets out there that have these comets are just, think of a snowball, and think of it breaking up at times. Every once in a while, pieces fall off of it. When they do, there's outgassing, and we see what we call, or what astronomers that watch these things, we call them as outbursts within the comets.
That would be a sudden brightening.
Sudden brightening. Great example was Comet Holmes that came through here a few years back in October, I think it was. We had it come through here, and it got its coma itself got to the size of the full moon. It was huge.
Yes, it brightened dramatically.
And what had happened was the entire surface of that comet, all at once, broke off, like pancaked off, and all new material was there, and it was still close enough to the sun that all that material sublimated all at the same time, and you got this incredible bow of a, it was gorgeous. It was absolutely wonderful.
Now, we were talking about comets that we can see. We'd like to talk about those types of comets. We've mentioned Hale-Bopp back in 1997, so that's 16 years ago now. And we've had a few since then, and we've got a new one coming up here in just about a month or so.
Comet Izon is due to be, and I use this term loosely, naked eye, because a lot of comets have reached naked eye. Basically, naked eye astronomy is anything over 5th magnitude. 5th magnitude is probably when you go outside from, say, anywhere here in the metropolitan Detroit area and you look up, the faintest star that you can see on a normal night is a little bit better than 5th magnitude, okay? The faintest star. So that would be considered naked eye visibility. A lot of comets have gotten to that. I have a number of pictures of some comets. We had Hale-Bopp up earlier. Here we see one of comet, I believe this one here is McNaught. That one was a southern hemisphere. There's, McNaught again, and then he just showed you Q4, I believe it was. Neat Q4. And that was another one that got naked eye. Very short time. We mentioned Comet Holmes. The one that everybody seems to be talking about now is Comet Izon, okay? Now, I warn everybody to get too excited about Izon. They're saying that you're going to be able to see it during the day. And comets, let me just say this straight out, comets are totally unpredictable. We got reports that the comet was brightening at a very high rate when it first showed up, when they first discovered it. And they said, well, this is a large comet, it's brightening at a high rate. This is going to be a gorgeous comet, it's going to be the comet of the century. Well, it went into conjunction with the sun. In other words, it went behind the sun and we lost it for a while. And it's just recently come back out and they can see it again. And their predictions are a little bit higher than what it's actually showing right now. It is beginning to catch up with those predictions, but I warn everybody to not to get too excited about this comet. It's going to be a good one, no doubt. It will go naked eye, but you may only be able to see it at night. I wouldn't get too excited about seeing it during the day.
Okay.
Okay. If it happens, great. We've got a couple of good pictures of comets here. There we go. This one here is, I love the name on this one. This is 73 Schwarzmann-Wachmann 3. And back in 2001, it went right over the Ring Nebula.
Yes, that's a great shot.
Yeah, I love that shot. And then I think we got one more. This one here is Comet Utsunomiya F1. And this one was back, and I can't remember what year it was. I think it was 2001. That little bright dot right next to the comet is Mercury. And I actually took this picture. It was through blades of grass on a knoll. That's how low in the sky it was.
So Mercury is the brightest spot in the center of our picture, and then the comet is just up at about the 11 o'clock position.
Exactly.
There, in a little lighter shade of blue against the the background sky. Well, that's a great shot.
Thank you.
That's a great shot. So Izon, they predict at its greatest visibility in what month now?
November, end of October, beginning of November, all the way through the beginning of next year. it should be visible. It should start being visible in telescopes probably by the end of this month and continue on all the way through the end of the year and into next year.
Will it be an evening or a morning comet?
It right now is a morning comet. It will work its way into the evening.
Oh, great.
Because they do that.
Yes, they do. So we'll have something to look forward to. We won't have to get up in the middle of the night to hopefully see this next great comet.
Let's hope it's a great one.
Yes, we'll keep our fingers crossed. I want to thank my guest, Mr. Mark Deprest from the University Lowbrow Astronomers, for all of his insights and knowledge about comets. I find it fascinating personally, so I want to thank you for being a part of our show today.
Thank you. I love talking about comets.
We're glad to have you here. Thank you very much. If you have a question about this show or really any other show that we've done, please send us an email. The email address is down at the bottom of your screen, again, as always. So check that out. We'd love to hear from you. And coming up next is What's Up in the Night Sky, so don't go away.
What's up in the night sky for October 2013? We're going to start out with the moons, and we have a new moon on October 5th. So the new moon isn't something to see in and of itself, but the sky is darker because there isn't a moon, and you get to see fainter stuff in the sky, especially if you go to you get outside of the city and you get to a darker sky site. October 11th is the first quarter. First quarter is visible in the evening. On October 18th, we have a full moon, and a full moon is visible all night long, sunset to sunrise. This one happens to be the smallest full moon of the year because the moon is at apogee. That's when it's farthest away from the Earth, so the moon therefore looks the smallest. We also have an eclipse, and I'll get back to that in a second. On October 23rd, we have the third quarter, and that's sort of a midnight to morning object. Back to this penumbral lunar eclipse. So, in a penumbral eclipse, the moon doesn't go through the darkest center part of Earth's shadow. It goes through what's called the penumbra. And so the moon only dims by a little bit. It dims by about 3%. It's hard to detect, under ideal conditions, it's hard to detect without photography, and then like really measuring it and all of that sort of thing. But in this time around, at least in Michigan, we only get to see this penumbral eclipse from when the moon rises until the end, so we only get to see part of it. And so most of the world can see bits of this eclipse. Africa can see the whole thing from end to end, but we only get to see the last bit. But the moon rises, at least in Michigan, around 5 p.m., and sunset is after 6 p.m. So you'll be seeing this slight dimming of the moon while the sun is up. I think that's beyond challenging. I think people would be hard-pressed to detect the penumbral eclipse, but that is on the 18th. The sun rises at the beginning of the month at 7:30 in the morning, and it sets at 6:15 p.m. By the end of the month, the sun rises around 8:05 and sets at 6:27. This turns out that the nights are getting longer, the days are getting shorter, so we have longer nights, and so you have longer nights to enjoy the night sky. And what I like about this time of year is that it's not yet freezing. You don't have to wear, you don't have to dress up like an Eskimo. You can be more comfortable. So, the moon, Venus, Mercury, and Saturn. I've picked October 9th for this image because Mercury is at its greatest elongation. That is, it's as far away from the sun as it gets. It's still going to be challenging. It's still going to be low over the horizon just after sunset. But Mercury is kind of a thrill to see if you can really spot it. Saturn is above it to the right. Venus is much brighter, is obvious. And the moon happens to be in the lineup on this October 9th. So if the weather's good, that's something to check out. Uranus and Neptune are up later. On the 3rd of October, Uranus is at opposition. That's when the Earth, the Moon, that's when the Sun, the Earth, and Uranus are in a line. So Uranus is as bright as it gets, it's as large as it gets. This is Uranus as shown from, as imaged from the Voyager 2 spacecraft, so that's up close and personal. It's a featureless blue ball, and so even in a relatively large Earth-based telescope, it's a featureless ball. You get to see a little disk. But it is really cool to see. And this time of year, you can see it without optical aid if you know where to look. You'll need a better chart than I've shown you on the screen, but it is possible to see it with just your eyes. Mars and Jupiter are after midnight. Mars rises at about 3:30, and Jupiter rises about 45 minutes after midnight. And this is a shot basically at midnight on October 15th, so the middle of the month, so that you can kind of see where they are. Mars and Jupiter are pretty bright, so it's really easier to say, oh, that's Jupiter, therefore it must be Gemini around there, than the other way around. Gemini is pretty easy to spot, though. There are 2 meteor showers this month. There's the Draconids, and they peak around the 7th and 8th of the month. And pictured here is the progenitor comet, Giacobini Zinner is the name of the comet. So the Draconids is not a huge meteor shower. It gives you about 10 meteors per hour, but it can be worth a look. On October 21st and 22nd, the Orionids meteor shower. This is a little bit stronger meteor shower at maybe 20 per hour, but the moon isn't quite as good in a position this year for this as it was for the Draconids. The Draconids, they're best in the morning, and the moon will have set by the morning, so you get out to a dark sky site. It's really good. One of the key bits about meteor showers is to dress warm. If you're just lying there and you're looking at the whole sky, you can get cold even in August. So dress warm. The Orionids is the dust from Comet Halley, which goes around about every 76 years. And that's what's up in the night sky for October 2013. Keep looking up. It's the greatest tree show that you can see overhead.